Hey guys, welcome to day 2, notes for Unit 1 in Algebra 2, and we're going to start talking and reviewing factoring. You learned factoring back in Algebra 1, and the very first type of factoring you learned was greatest common factor, and so we're going to review that first. Remember what factoring is. Factoring is actually just the opposite of distributing. When you put expressions together with multiplication to take them apart, that's factoring. So here we go. We are going to go ahead and look at this example right here, but we want to pull out the greatest number and the greatest variables that we can from each term. In this case, there's 2 terms. I always check the lowest number, which is 6. Does 6 go into 15? It doesn't. So now I have to go lower. The other numbers that go into 6 are 3, 2, and 1. Well, of those numbers, 3 goes into 15, and that's the largest number that goes into both. So we're going to pull it out. Shouldn't say leftover just yet. We have to look at our variables too. We forgot about them. And x squared is the most amount of variables you can take from both terms. Even though the x cubed has another x to give you, the x squared doesn't, and so that's why we can't take more. Now we're going to go ahead and put our parenthesis, and we have to think about what's going to be inside. In order to distribute this 3x squared to something inside to get the 6x cubed, we're going to need a 2. Because that's going to give us the 6. We're also going to need an x because when we multiply, we add the exponents. And don't forget, there's a little tiny 1 right here. You can put it if you want. Okay, but this should give us our first term. And so now we're going to work on getting the second term. And we're going to need a minus. And if we have a 3 on the outside, we're going to need a 5 on the inside so that if we multiply 3 times 5, we get 15. And the x squared's already outside, so we don't need anything else. Okay, and just a real quick, if you want to check it, think about what this gives you when you distribute. It should be the first term. And when you distribute the second time, that should give you the second term. Okay? And so that is our answer. If we go down here and look at number 1, between 10x and 25x squared, the largest number I can take out of both is 5. And I can take out an x. Left over would be a 2 minus 5x. And again, you could quickly check it. This would give you the 10x here. And if you distribute one more time, that should give you the negative 25x squared. And so this is my answer. That's factored. Okay. On to this one. There are no numbers, which actually makes it easier. So looking at the a squareds and the a, the most I can take out is an a. Looking at b and b squared, the most I can take is b. Left over would have to be an a here, so I get the a squared b for the first term, and then keep my plus sign. And I would also need a b here so that if I distribute again, I would get the ab squared. And close them up, and this is done. On this one, 8 does go into 56, so 8 must be the largest number. Of those a's, I can go ahead and take out a squared. However, there is no x on the second term, so we cannot pull out an x out of both. Left over is going to have to be an a squared in order to get that a to the fourth and an x. And then a minus, and we're going to need a 7 because 8 times negative 7 is negative 56, and the a squared's already outside. I'm going to close them up, and this one's done. Down here, we have 48 and 36. The largest number that goes into both is 12. We are allowed to take out an x squared, and we are also allowed to take out a y. Left over, 12 times 4 is 48. And all the variables are outside there already, so we don't need that. And we're going to keep the plus. 12 times 3 is 36. We need an x and a y to get the x cubed and the y squared. Close it up. This one's done. On this one, 49 actually does go into 147, so 49 is the largest number. Of the x's, we can take out x to the fourth. Of the y's, we can take out y squared. Left over, we're going to need an x right here. And that's actually it to get that first term. Then we need our minus sign. 49 times 3 is 147. And we're also going to need a y. This is done. One last one. Out of those three terms, looks like 3 is the largest number that will go into all of them, and we can take out an x squared. Left over will be an x squared and plus 7x. And a lot of people want to close this up right here, but you can't. If you do, you would only distribute twice, getting only the first two terms, not all three terms. So a lot of people, even though this matches what we have outside, you need the -1 in here so that you distribute 3 times, getting all 3 terms that you started with. Okay, on to the next type of factoring down below. It's called difference of two perfect squares. I think it's the easiest. Okay. What is a perfect square? First off, we have lots of perfect squares. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and they keep going forever and ever and ever. So those are perfect squares for numbers. So if you look at all the numbers in all 6 of these problems, they're most likely there unless they go past 100, like 121 and 144 and 196. What about variables? If you look at all the variables, you're going to recognize something. Every single one of them has an exponent that is an even number. And that's because only variables with even exponents are considered perfect. So x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, and so on. They go on forever as well. All right, why are these perfect squares? Well, let's say we take the square root of 49. We get 7. 7 times 7 is 49. That's why 49 is a perfect square. It's made up of two numbers multiplied by themselves, and it gives you the number. So why is x squared perfect? Well, the square root of x squared is x because x times x is x squared. If I take the square root of x to the 4th, that's x squared because x squared and times x squared is x to the 4th. Remember, when you multiply, you add your exponents. So with that in mind, what's the square root of x to the 6th? It's x cubed. So if you're trying to generalize, what are you really doing to the even exponent that makes it a perfect square? You're cutting it in half when you take the square root of it. Okay? The other part besides the perfect squares is that difference. Difference means that you have to have subtraction between the two terms. So if you take a look at each example, there's two terms separated by a big fat minus sign. All right, and that's why these are all difference of two perfect squares. Now, when you're factoring, remember the first type of factoring you're supposed to check for is greatest common factor. So in number 7, there is nothing in common. Okay? He doesn't have any numbers. He doesn't have any variables. So there is nothing in common. However, we do have the difference in the middle, and this is a variable with an even exponent, and 1 is actually our very first perfect square. And so a lot of people overlook this as a D2PS. It's the most commonly missed D2PS to be factored. When you're ready to factor a D2PS, you separate it into 2 sets of parentheses in order to put its 2 factors in there. We're going to go ahead and take the square root of the first term, and the square root of x squared is x, and so x gets the first position. 1 is going to get a positive sign, 1 is going to get a negative sign. That's how D2PSs work. Then we take the square root of the second term, and the square root of 1 is 1, and 1 gets the second spot, and that is factored. If you were to put those back together, you would end up with x squared minus 1. Okay. In number 8, there is nothing in common between 16 and 81 besides 1, and that doesn't count. But if we go to difference, we have the difference sign in the middle, the subtraction. 16 and 81 are on my perfect square list, and those are variables with even exponents. So we're going to go ahead and separate it into 2 sets of parentheses. And we're going to take a square root and square root the first term. And the square root of 16y squared is 4y. 1 is going to get followed by a plus sign. The other one's going to get followed by a minus sign. Doesn't matter which one's which. Then we're going to take the square root of 81x to the 8th, and we end up with 9x to the 4th. Remember, you're just chopping that exponent in half when you take the square root of it. 9x to the 4th. Neither factor can go again, which is something we're going to have to pay attention to coming up. And that one's finished. Next one up, anytime you have fractions and you're asked to factor, automatic D2PS. So we're going to go ahead and set up our 2 sets of parentheses. And we're going to take the square root of the first one. And it looks a little scary, but when you take a square root of a fraction, it's just the square root of everything in it. So the square root of 4 is 2. Square root of 81 is 9. Square root of x to the 4th is x squared. We're going to follow this with a plus sign. And we're going to copy the same thing in the second factor, except we're going to follow this one with a minus sign. Then we're going to take the square root of the second term, which is 9 over 49. And so it's just the square root of 9, which is 3, and the square root of 49, which is 7. And we're going to copy it over here. And that is factored. Wasn't that bad. Okay. Coming down here, again, a fraction, automatic, D2PS. Square root of 25 is 5. 1 with a plus, 1 with a minus. Square root of x to the 6 over 144. Square root of x to the 6 is x to the 3rd over square root of 144 is 12. Copy it over here. And that D2PS has been factored. Next one up, 2 sets of parentheses. It's a difference of 2 perfect squares. Take the square root of x to the 10th. You end up with x to the 5th. Remember, you're just chopping the exponent in half. 1 with a plus, 1 with a minus. Square root of 196 is 14. And this has been factored. Last one, he's a little bit long. Let's see if we can squeeze him in here. Okay. Square root of all that stuff. Not that bad. All right. You get 4x to the 3rd, y to the 7th, followed by a plus sign. 4x to the 3rd, y to the 7th, followed by a minus sign. Then we take the square root of the second term. Square root of 121 is 11. Z to the 4th. 11 z to the 4th. And that one's done. Ta-da! All right, I'll see you on the backside for a new type of factoring called factor by grouping.